Welcome back guys. So another video of my channel Infinity Tech. Today we are going to discuss about the basic explanation of the logic gates. Basic of logic gate. So today we are going to discuss about the basic of logic gates. So what is the logic gates and what is its internal structure and what is the truth table of logic gates? So that's all the things we are going to learn in the today's related video. Okay, so first of all the basic gate, we have the three basic gate. Okay, first one is OR gate, second one is AND gate, and last one is NOT gate. These three are our basic gates, while the four and fifth, it is a universal gate, and that is NOR gate and NAND gate. This is our universal gate. Universal gate. Right friends? And remaining the 6 and 7, that is XOR gate and XNOR gate. It's called the extraordinary gate. Okay? So in this video we are going to discuss about these basic gates. Okay, so first we talk about the OR gate. What is the OR gate? Okay, so as a electrical point of view, we can compare the OR gate with the internal, with the two switches connected in parallel. Suppose the OR gate is represented by this sign. Suppose this have input 1, input A and input B, then the output of NOR gate y is equal to, it's called given by A plus B. Now as the electrical point of view, we can give the OR gate as suppose it's have a one switch, namely A, and it's have a second switch with the name of B. Okay, so as an electrical point of view, you can compare the OR gate with the two parallelly connected switch as shown in the given figure, where we are taking, suppose it says a positive terminal and it says the negative terminal. Then we have here any lamp load, that is called R, is connected here. So if any one switch, if either A or either B, any one switch will activated, it means any one switch will be closed, then the current will flow and we will get the output 1. So that means the this OR gate will act as a parallelly connected switch. If any one input is higher, then output will be higher. So for the truth table of OR gate, we will get uh, here we will get the column A, column B and column Y is equal to A plus B. So here input combination will be 2, because of we have the two variable, we are having a 4 output condition. Right? It says a 0 0 0 1 1 0 and 1 1. If any one input is higher, then current will flow. So if any one input will present, then the current will flow, then the output means high. Both of the element will present, so output will be high. And if no switch will be closed, then the output will be 0. So this is a truth table for the OR gate. This is a circuit diagram. As the electrical point of view, this is a circuit diagram for the OR gate. Okay friends, and also as a internal circuit structure, suppose we are drawing the structure with the transistor, so we can take it as suppose here we have taking the output V0. Okay, so we have the another transistor here, which is also give, it's your B, it's our A, and this both transistor are connected to the plus 5 volt supply. So what happen actually, here we also we will get output V naught. Okay, actually we will get the output V naught from here. So what happen, if any output A, if any transistor A or B will be active, if any transistor A or B will be active, then the suppose the A will be active, so 5 volts are given to the V naught from this position, and if the B will active, then the 5 volts are present from the this position. Okay friends, so this is the basic of OR gate, where this is a symbolic representation of OR gate. This is the electrical point of view. We can summarize the OR gate like this. This is the truth table, and this is the internal structure of the OR gates. Okay friends, now for the second gate will be our AND gate. So now what is the AND gate? So AND gate is similar to the parallel. AND gate is similar to the series switch, means it will act as a two switch connected in parallel format. Like this is a switch A, this is a switch B, and suppose it will connect it to the supply, and across this we have connected a load R. So what happen, if A will be on but B will be not on, so the output will be 0, means okay, there is no current flow from the load. Okay, so in order to flow the current from the load, we need to turn on both the switches. This can be represented by, AND gate can be represented by this format. It's have a A, it's have a B, and output we have a Y. And Y is what? Y is A dot B. This is a representation of the AND gate. Okay, so this is the symbolic representation. It is the electrical point of view. We can represent it by this circuit diagram. And for the transistor view, we can represent it by the two transistor connected in this format, where can connect the transistor like this. It's our A, it's our B, and we are taking the output from V naught this, and here we have 5 volt plus 5 volt input. So if A and B both will be on, then the input voltage will be to our output voltage. Okay friends, now the truth table for the AND gate, we can draw like this: A, B, 0 0 0 1 1 0 1 1. So we can make the truth table for Y. If the both of the transistor will be on, then the output will be on. So it's have only one here, remaining all the parameters are filled with the 0 point. Okay, so this is our basic AND gate circuit. Now we are discuss about the third basic gate, and third basic gate is NOT gate. Okay, third gate is NOT gate. So in the NOT gate, this will invert the input, like that. Means if the input is 0, that will give the output 1, and if the input is 1, that it will give the output 0. Okay, so NOT gate will be represented by similar as a diode, but it's as a this symbol will be indicate the NOT inverting operation. This will indicate the inverting operation. Suppose it's our input A and output Y will be represented by A bar. Okay, so as a transistor mode, we can represented by represented the OR gate circuit like this, where we have the input A and we are taking the output from this point. This is your V naught, and this will connected to plus 5 volt power supply, and this will connected to the ground. So what happens friends, whenever we have the A, we have output I. Okay, so in input condition is what? 0 and 1, only two possibilities. Okay, so what happen? 0 and 1. Okay, now so what happen when the input is 0? When the input is 0, the transistor will in off state, and it's ideally it's have infinite resistance, but in short, where the when the input is 0, it will act as a turn off mode. It will in turn off mode, then the output voltage will be the input plus 5 voltage, and it will taken as a 1. When the input is 1, that means transistor will act as a on switch, and it will act as a short circuit. So this V0 will be connected to the ground potential. So V0 value, which means 0. Okay, so this is the basic gets we can conduct. Okay, so in this video we are learn about first the 3 basic gates, that is OR gate, AND gate, and the final is NOT gate. These are our basic gate. Okay, so thank you guys for watching my video, and if you like, please share and subscribe this channel. Thank you guys.